All right, 7.8.1, we're kind of shifting back a little bit, back to some more basics. We're going to talk about samples and populations in this lesson. And so this chapter is a bit of a kind of back to statistics where previously we had talked about proportions and ratios and percentages and probability, and we're kind of going to go back to that a little bit now. So samples and populations is where we're going to start. Let's start with some definitions. An unbiased sample. We are always looking for unbiased samples in order to draw conclusions about data. Your data has to be unbiased in order to be true. So an unbiased sample represents a random population. Taken at random, it's a large enough group, so it has to be big enough to provide accurate data, and it has to be from a variety of sources in order to be truly unbiased. So, if you're going to ask this statistical question like, is soccer a fun game? And you only ask the soccer team, you're going to get different answers than if you actually poll people who play soccer, people who don't play soccer, people where, maybe there's a lot of soccer teams, or from where there's not a lot of soccer teams. Like, you're going to get different answers if you truly poll or find data from a random number of people versus a more biased number. So random population, large enough to provide accurate data. And then a biased sample would be the opposite of this. It doesn't represent a true population. So it's not representative of the whole group. It's representative of a small part of a group that doesn't truly show what the whole group might think. Okay, the things that make a sample biased is that maybe they favor one or more parts of a population, for example, the soccer team. Or maybe the sample's too small. If you only survey 3 people, that might not give you a really good idea about how people feel about something if the sample size is too small. So a large group and among a wide variety. The other thing to note is that a sample is smaller than a population. So a sample is a small piece of a wider population. So, our 7th grade class would be a sample of the middle school. If I wanted to poll the class on whether or not we should, I don't know, I'm trying to think of an example, go outside for lunch tomorrow, and I wanted to use 7th grade as my sample, I would assume that what 7th grade thought would be a model for what the rest of the middle school thought. But you would be my sample because you're a smaller portion than the entire population. All right, let's do a couple examples. All right, example 1 says this. You want to estimate the number of students who ride the bus to a local high school. So you're going to make an estimate from a sample to find out how many students ride the bus to the local high school. So we're going to go through each of these and figure out which one would actually represent an unbiased sample. So from a variety of people, a variety of backgrounds, variety of interests, places, etc., and a large enough amount. So which one's unbiased? 4 students in the hall, all the girls on the soccer team, 50 random 12th grade students, or 100 students at random during lunch. So let's look at each of these and determine if it's biased or unbiased. Letter A, 4 students in the hall. This is not an unbiased sample. It is not big enough. That might be a random, group. It might be, not all kids just walking off a bus, but it's just not enough data. 4 students doesn't give you a good idea. So that's not going to be unbiased. All the girls on the soccer team leaves off an important population at a local high school, which is boys. So, and it leaves off other students who might not play soccer, and maybe the kids who don't play soccer are more likely to take the bus, or who knows. So this doesn't give us a wide enough population. It's not a diverse enough sample in order to make a good conclusion from our data. So not B. C, 50 random 12th grade students. This is not unbiased either, because now you're only polling 12th grade students. And that can skew our data because 12th grade students are usually older than 16. They can drive. It's less likely that they'll take the bus if they're able to drive, or maybe they have friends who can drive, and so they go with their friends and they don't take the bus. So this is not going to be an unbiased sample, which leaves us with D, 100 students. That's a large sample size. And you're pulling them at random during lunch. So that gives you a better idea and a better chance of getting accurate data from a large group random sample. Okay, now this is key in being able to make conclusions about data. The results of an unbiased sample will be proportional to the results of the larger population. So if you poll, from the last slide, 100 students at a high school, and maybe there's 1,000 students in the school, you would expect that if, 40 out of 100 took the bus, that 400 out of 1,000 would also take the bus. So you expect to see proportional results from your data. And we can use these unbiased samples to draw conclusions about a larger population. You cannot use biased samples to draw conclusions because they will not be accurate. So if you poll kids getting off the bus about if they take the bus to school, you're going to get a really high number of kids that take the bus, right? Like 100%. And that's not true. 100% of kids don't take the bus, but you had a biased sample, so your conclusion is not valid. So be careful about your samples in determining whether or not they can make conclusions about a population. Here's an example. You want to know how town residents feel about adding a new landfill to the town. We're going to look at two different examples and determine if the conclusion that the researcher made is valid. Let's look at the next page. All right. So first, you're going to survey 100 residents whose homes are near the site of the new landfill. 100 residents near the new site of the landfill. Here's our conclusion, or here's what the results found. 90% of these people are against the new landfill, and 10% are for the new landfill. So what this is saying is that these people generally don't want the landfill. And so the question is do they determine how the whole population feels? Is our sample unbiased? This is our conclusion. And we need to determine, is that valid? So you conclude from this that 10% of all the town residents support the new landfill. So very few, right? They don't want this. But that's not a valid conclusion because the sample size was biased. They only surveyed people whose houses were going to be near the new landfill. And obviously, they wouldn't want to have a landfill right next to their house because it's gross, right? It smells bad. You have trash trucks coming in and out, dumping people's trash, and it's gross. So this is not an unbiased sample because these people are generally going to answer no. Now, if you truly took a random sample of the whole town, people who live all over the place, you might get a different answer. For example, you survey 100 residents at random. So we've got a good sample size, and now we're going to poll people from all over town, not just those near the new landfill site. Here's our table. 40 people out of the 100 support the new landfill, and 60 people do not support it. So out of the 100 we polled, those are the answers we got. Your conclusion is that 40% support the new landfill, right, from here. 40% support the new landfill. And we would conclude from that probably 40% of the whole town, which is more than 100 people, would support it. Is this valid? And in this case, we could say, yes, this is probably a valid conclusion based on the sample. data, the sample data that we got, we can say that this is valid because it was a large sample size and it was random, wide group of people that we polled. Here's another one. You asked 75 students how many movies they watch every week. The results are shown in the graph. So this is 75 students, and they all answered how many movies they watch per week. So 30 of the students said they watched no movies, 20 students said they watched one movie, and 24 students said they watched 2 or more movies. The question says, if there are 1,200 students at the school, how many can you assume watch one movie per week? So we're going to be using this. I'm going to do this in yellow so we can see it. This piece of our little pie chart is going to be the one that we're going to use. So this goes back to proportions and ratios. We can assume that this pie chart of 75 students will be proportional to the bigger population of 1,200 students. So remember that we can set up proportions to compare ratios that would be equal. And we know that if 21 out of 75 students, that's based on our pie chart, watch one movie per week, that should equal that same proportion of students watching one movie per week out of 1,200. So we set up a proportion, two ratios that are equal to one another. We put the students watching one movie on top over the total on the bottom. And this we would expect because we took an unbiased sample and collected good data that we could set this proportion up to model the bigger population. Now, to solve a proportion, to solve for x, we cross multiply. So 75 times x is 75x, and 21 times 1,200 is 25,200. We set these equal to each other. So we say 75x equals 25,200. And my last step is to solve for x. I divide by 75 on both sides. So we get x. Out of the 1,200 students in the school, we get 336. So if it is proportional, we would expect that 336 students out of the whole 1,200 in the school, about that many would watch one movie per week. So use proportions to be able to solve for missing pieces and to make conclusions about larger populations from the samples that you gather. All right, a quick note on homework tonight before you get started. There are no checks on the homework tonight. So just beware of that. It's not a mistake, it's on purpose. Most of these are multiple choice, and I want you to make thoughtful choices on your multiple choice rather than just using the check feature to tell you which one's correct. So when you're asked, is this an unbiased sample, you'll have to answer yes or no. And you'll have to, there'll be, the box that says explain or whatever like this. So you'll choose your yes or no. And then you explain why. Like, yes, it is an unbiased sample because it's, a large number and it's a random population or whatever. So there will not be a check button. That's not a mistake. Just take your time, go slowly, and be thoughtful with your answers.